let's go through this. All right. All right, so in situation A, your 3 different basketball teams each have played 5 games. Okay, the first question, suppose you want to join one of the 3 basketball teams. You want to join the one that's doing the best so far. Rank the teams by the mean score. Which team would you join? Do you know? Jaguars. Good. Okay, because it did have the highest average. Okay, instead of using your mean scores, you use the median score of each team to make your decision. Which team would you choose? Louise? The Wolves. Good. Okay, then pretend you are a coach of the Lions and you are being interviewed about your team for the local newspaper. Would it be better for you to use your mean score or median score? Liam?
The mean score was 68.2, so
Good. Okay, so the mean score was higher than the median, so that's going to make your team look better. Okay, the average was 68.2 as opposed to the median, which was 65. How many of you did get all 3 of those correct? As you should. Awesome. Okay, situation B. You and your friends are comparing the number of times you have been to the movies in the past year. Okay, by comparing the modes, which person went to the movies the least per month? Nolan? Mary, good. Okay, if you look at her modes, it's all 1. By comparing the medians, which person went to the movies the most? What do you think? What did you notice? They're all the same. Okay, so they're all the same. What was the median? 2. 2 for all. Okay, they were all the same. Rank the friends in order of most movies seen to the least. Okay, who is number 1? Sabrine? John? Anybody else? Tied for number 1? Taylor? Brian. Good. Brian and John. Okay, how about number 2? Paris? Kelly? And last but not least would be Mary. Okay? So which month, by comparing the means of movies seen in each month, is the most popular movie watching month? Someone I haven't heard from yet. All right, so Wes, what do we got for number 4? July. Good. July. And by comparing the medians, which month is the least popular month? Caitlin? January. Okay. So then, what is the mean of the medians? So you got to take the median for each month, okay? Then take the average. Anyone have that? Nolan? Good. 2.08. How many of you did get that? Okay. What you had to do is 2.083 if you did. Take the median of each month, okay? So what is the median for January? What is that written? Do you know? One. Okay, then February it was 2.5. March 1.5. April 1.5. May 3. 5. 2.5. 2. 2.5. 1.5 and 2. So once you take the medians, you then take the average. So you add all those up and divide by 12. And that's how no one got the 2.08. Okay, yep.
So if we round that answer to the nearest 10.
It doesn't say, so that would be fine too. Doesn't say. Okay. When in doubt, we always kind of default to the hundredths place, but again, it's in the same ballpark, so that's fine. All right, so that was just a quick little warm-up on our first lesson, okay, the 4.1. Hold on one second. A few people that weren't here. So what are some things you learned from last class? Nolan, what's one? Okay. Standard deviation. Anyone remember what that means? Brayden?
Like how similar the data is.
Okay. There's one key word. Yeah, Nolan. Okay. So that's how we use the standard deviation for a normal curve. But what else? What about standard deviation? Something else. Yes, Ian. Yes, the amount of variability or the spread of the data. So going along with what Braden said is it's the average distance from the mean. That's the technical terms of it. So you're looking for how spread out the data is. If it is close to the mean, so think of your test scores, right? I want to look for a small standard deviation. That means the majority of you are around the average. So most of you, let's say, think on the midterm it was 89 point something average, and your standard deviation was 3. That's awesome. That means the majority of the data is around that average. If we have a larger standard deviation, let's say a 15, and there's no benchmark total to say if it's large or small. If it's a large standard deviation, you have some outliers, or there's a lot of variability in the data set, okay, where there's data like kind of scattered throughout, okay. Standard deviation in the calculator is denoted with SX, okay. So standard deviation talks about the spread and the amount of variability. What else did we learn? What's another thing? There's about 20 of you here. Yeah, Liam.
I think when it comes to data specifically, I think either skew left, skew right, or being symmetrical.
Okay, so you have symmetrical. Skewed left. Or skew right. What do we look for these guys? What do we look for? Yeah, Louise. Look at the tail. Excellent. Okay. So what she means by the tail, it's just one tail. Okay. If it's skewed left, okay, the majority of the data, if you're looking at it, is going to be on the right-hand side. But we're looking for the tail. Okay, that's not the greatest picture. But where the tail fans out is where you tell if it's skewed left or right, not where the majority of the data is. Okay, if it's skewed right, you have that tail going out that way. Okay, not the greatest pictures, like I just said. So if it is symmetrical, okay, if it's symmetrical, it's a normal curve on either side. What else goes along with determining if it's symmetrical, skewed left, skewed right? Addison. Good. So mean and median have a lot to do with this. Okay. If it's symmetrical, what's the deal with the mean and median? They're what, Danielle? Good. The mean is pretty much equal to the median. How about if we're skewed to the left? Yeah, Genevieve. Good. Mean is less than the median. Meaning you have an outlier lower than the average. Okay, dragging it out. Skewed right. Liam?
Mean is greater than.
Good. Meaning you have a higher outlier, dragging it in the other direction. Okay? So symmetrical, skewed left, skewed right. That talks about the shape of the distribution. Okay? Standard deviation talks about the spread. Okay? The center is the mean and median. So those are some keywords you will hear as well. Shape, center, spread. And that's referring to all of this. What else? Louise? Okay, so our different graphs, our different visual representations. We have our dot plot. We have our box plot. Anything else? Saying? Histogram. Good. Okay, one thing with the box plot. What do we find out in order to create those? What is that called? Something we could find in our calculator. Yeah. The min and max, what else? Louise? Excellent. The 5-number summary. Which is the minimum, quartile 1. Okay, the minimum is also the lower extreme. Quartile 1, the median, or quartile 2. Typically, we just use the median now. Quartile 3, and the max. What else with the 5-number summary? Or with box plots? They're divided into what? Yeah. 4 quartiles, each representing 25% of the data. So from minimum to quartile 1 is 25, quartile 1 to the median is 25, median quartile 3 is 25, and that's 25. It doesn't matter the length of these, it's automatically 25% of the data, okay? The 5-number summary is used. What else with that 5-number summary? There's one other term we use there. Talks about the middle 50%. Yeah. Excellent. Good job. The interquartile range is the middle 50, which is quartile 3 minus quartile 1. It's where the majority of the data lies. Okay? Now, if we were looking at skewed, if there's any sort of outliers, extreme outliers, the median and the interquartile range we would use more as opposed to the mean and standard deviation. Because the standard deviation will definitely throw off your average and the skewness. Okay? Was there anything else that we went over? Okay. Any questions on the practice? I saw some of you crossed out a few things or wrote question marks or whatever it was. Starting on page 3 in the green packet, you had 15, 21, and 22. Danielle? It would remain unchanged. 21, you actually had to find it. Find the difference. Yep. You're welcome. 15, 21, 22. Questions, Lila? 21? Sure. Okay, so some of the examples we saw in class was changing all of them, right? So the mean and median, everything would change. But here, there's only one person changing. So you kind of have to work backwards. You know, thanks, Sam. You know the mean mass of 5 members is equal to 74.5. That's how we found it out, right? The mean. So we have to kind of undo this. We have to multiply 5 times 74.5, right? Is that it? Yeah. This is the formula on how to find mean. X is our mean. Okay, the total. Divide by 5 equals 74.5. So once we go this way, we know that 74.5 times 5 was 372.5. That's what we started with regarding adding all their what's it called? Masses together. Okay? Now, it says if one person loses 5 kilograms, only one person. So we would take our total and do what to it? Nolan? Subtract 5. What would we do if all 5 lost? Yeah. Yes. You could, because everything would change, right? So we wouldn't have to do this extra step. But since it's only one person, we have to subtract 5 from it. So then what do we get? What's 372.5 minus 5? No, Liam. 367.5. Oops. 367.5 is our new total of mean masses. Now we have to find the average again. So 367.5 divide by 5, and that's how you get the 73.1, I believe, percent. Not percent, it's because your new mean mass. Okay, so if 173.5, I looked at the wrong one, okay, is your new mean mass. Okay, I was looking at the above one. They both happen to be 73. So anytime there's one changing, you kind of work backwards and you subtract. If all of them were losing 5, you would just take the total and subtract 5. Okay, questions? Yep. It's in the green packet. Okay, now page 4, 5, or 6. Any questions on those? Brayden? Yep. Mm-hmm.
I was kind of confused because. Oh wait, never mind. I get it. Sorry.
Are you sure?
Yeah.
Okay. Genevieve? Mm-hmm. From doing this way too. Yep. Did you get the same thing? Like if you were? Yep. That's another way too. But typically we go from that. But again, here if it's 1, then you can do the same thing for all. Okay. Any other questions on the homework? Okay. Before we get to some additional practice in the green packet, we will get to that shortly. I need you to take out your Chromebooks and or laptop. And the scores were released once updated, so we'll see what you got. According to the Box and Whisker, what is the lower quartile? Anytime you're talking about the lower quartile, you're looking at quartile 1. Okay, it will automatically say the lower extreme or minimum if it's talking about the minimum value. Okay, so that was a big difference I saw between 65 and 75. The lower quartile is always quartile 1, so that first line there. What is the median? What did these go up by? 5, which everyone got correct, was 30. Good. The mean, okay, you had to add these all up and divide. The median, straight answer, 70. The mode, how many modes were there? 2, 32, right? And 94. So you put a comma in between. The range, max minus the min. And this last one here, paid the following for his last 6 pair of jeans. Roughly you want to know which one measure of central tendency would be the best to describe how much he roughly spends on jeans. And what would it be? Yep. The median, because there was the one outlier of 125. Now, some of you, this was at a 2. Now, some of you got a 1 out of 2 because you didn't explain why. Okay, that's typically what you're going to see in these types of questions. Okay, you always want to back up your decision as to why you chose any of the measures of central tendency. All right, any questions on the exit ticket? And it was just to see where everybody is from 4.1 to 4.2. Okay, We are going to go over those problems in the green packet in probably about 5-10 minutes or so. If you are finished with those, here is a review guide, but it's only the circled problems I want you to complete. This will be your homework. Okay, the circled problems in this packet that once you're done with those, you pick up and get started on. Okay, this is part of your test review. Okay, it has a little bit of the next lesson we will be doing. But it's to make sure, again, there's a lot of little content here and there that we want to make sure we're good with. All right, so that's first. The green packet is first. Finishing off those problems, we will go through those in about 5-10 minutes. Okay, if you are done with those, then you may come pick these up. Okay. Okay, for number 11, what was the median, Jackson, for number 11 in the green packet? 17, excellent. What was the smallest number? Let's see. Grace, for number 11. 9, excellent. What is the range, Jack, for number 11? 16, excellent. What is the third quartile? Let's see. Emma. 21, good. What is the interquartile range? Let's see. Is that over there? Stacy. 6, excellent. Okay, for number 12, what is the total number of students in this class according to this histogram? For number 12, Assad. 26, excellent. All right, number 13 is a little bit of a challenge because this is a cumulative histogram where it builds upon itself on the previous one. So you have to be careful. According to the table shown, how many total people passed the driver's safety exam? Sabrine? 20, good. According to the table shown, how many people answered 49 questions correctly? Esteban? 5 is correct. The difference between 14 and 9 is 5. Okay. According to the table, how many people received a score of 48 or less? Brayden? 9. Good. Excellent. Good job. Now we have two histograms here, Wheatland and Urbandale, okay? And these are all about or approximations, okay? About what percent of students at Wheatland get at least 8 hours of sleep per night? Liam?
45%.
45 might be a little bit less than that. 41-ish. Okay, because you're adding together for Wheatland 30 plus 10 plus 1-ish. Do you see it?
Oh, yes.
There. Okay. All right, for 15, about what percent of Urbandale gets at least 8 hours of sleep per night? Louise? 28%, 27%, depending. But you're looking at these 5 bars here. Okay? Which high school has more actual students that sleep between 9 to 10 hours per night? Yeah. Good. Perfect. Which high school has a higher median sleep time? Yep. Wheatland. Good. All right. And then for 18, the test scores for 10 students are as follows. Which frequency table is the accurate? Which one do we think? They filled out the intervals for you. What do we got? Blake, what do you think? B is correct. Good. B is correct. They have the intervals. So from 61 to 70, you look to see how many scores fit in there. 71 to 80, there were none. 81 to 90, okay, right here. Add those up, okay. And then these guys here. And then 91 to 100, there was 2. So this was the best frequency table. Then for number 19, what's the total number of students? Who's got that last one for us? Ellen? C, 16. Okay, there was a 16 amount of students. So the whole idea when you get to problems like this, a lot of these, if you notice, they're kind of SAT type questions. There's a lot more of the SAT questions that we will see. It's the way the question is formed, okay? You have to figure out what it's asking. You guys know the material, can decipher. You just have to be specific depending on the question, okay?